This lesson deals with an NPN PNP example. You can find these notes in the course ebook in Chapter 10, starting on page 11. Given this two-transistor circuit, could you find the current I and the voltage V given the transistor parameters of V sub BE on equal to V sub EB on equal to 0.7, and that V sub CE sat is the same as V sub EC sat equal to 0.2 volts, and that beta F for both transistors is 100. You can assume that Q1 and Q2 are in the active region and then verify the results. For us to put the models in, we need to identify the transistor's terminals. So here is the collector of transistor 1, the base of transistor 1, and the emitter of transistor 1. Here's the collector of transistor 2, the base of transistor 2, and the emitter of transistor 2. Now we're going to replace the transistor with its active region model. I've drawn the schematic exactly as it was on the previous page, except that I'm going to erase the transistor, here's Q1 and here's Q2, and put in the active region model. Between the base and the emitter of transistor 1, there's V sub BE on, which was 0.7. Between the collector and the emitter of transistor 1, there's a current source of beta FIB 1. You have two transistors, so we're going to use subscripts 1 and 2. Here's the voltage from the collector to the emitter of transistor 1. I have to check that that's greater than or equal to 0.2. And then for transistor 2, between the emitter and the base, voltage source of V sub EB on equal to 0.7. Between the emitter and the collector of transistor 2, I've got a current source of 100 I sub B2. I sub B2 is coming out of the base terminal. And there's a voltage across the emitter collector of transistor 2. I need to check that that's greater than or equal to V sub EC sat, which is equal to 0.2. This part of the circuit really is disconnected from this part of the circuit because there's no wire going between them. Just simply one wire, and whatever current goes in there has to come right back again. So this is really separate from this circuit. Let's start over here, work our way to the right. The base current of transistor 1, I need to check that that's greater than or equal to 0. And I could find that by finding the voltage across this resistor and then dividing by 15 megohms. This node voltage is 15, this is 0.7. The difference of those two over 15 million is 953 nanoamps. Is that greater than or equal to 0? Yeah. The collector current would be 100 times bigger, and that would be 95.3 microamps. And that's equal to I sub B2. I sub C1 equal to I sub B2. And I have to check that that's greater than or equal to 0, and yes, it is. Now I need to check that the collector emitter voltage is the right size, so let's do a loop. The rising voltage is V sub CE1, the rising voltage of 0.7. Let's go around the loop this way. I have a voltage back to ground. The rise in voltages have to equal a drop of 15 volts. I can solve for V sub CE1. It'll be 15 minus 0.7, which is 14.3. That is greater than 0.2, so that checks. Now I found the base current of transistor 2, so the collector current is beta F times bigger, which was 100 times bigger, or 9.53 milliamps. So now I know this current over here. My voltage V is going to be equal to this current times 1K. E is equal to 1K times I sub C2. The K's in the milli cancel, I get 9.53 volts. Next, I got to check that this voltage is the right size. Let's do a loop equation. The rise in voltage is V, the rise in voltage is V sub EC2, and the drop is equal to 15. That's my next equation. And now I can solve for V sub EC2 as 15 minus V, which was 9.53, and I get 5.47. Is that greater than V sub EC sat? Yes. Then lastly, I want to find the current I. Let's go back to the drawing. Current I is equal to this current plus this current. It's going to be equal to I sub C2 plus I sub B2. We've already found I sub C2, so let's just use that. IB2 to I sub C2 at 9.625 milliamps. Now since IB1 is greater than or equal to 0, V sub CE1 is greater than or equal to 0.2, and I sub B2 is greater than or equal to 0, and V sub EC2 is greater than or equal to 0.2 volts, then our assumption that Q1 and Q2 are in the active region is correct. And this is an NPN PNP example.